Have you ever wondered how a jet engine actually works and what makes it so powerful? A jet engine is essentially a machine that converts energy into thrust, but how does it do that? Imagine you're blowing on a pinwheel. When you blow, the air moves fast and spins the blades of the pinwheel. Now, think of a jet engine as an amplified version of that pinwheel. Inside a jet engine, there's a fan that grabs a huge amount of air from the front and pushes it through the engine core. And here's the surprising part. As the air gets pushed deeper into the engine, it passes through something called combustion chambers. Here, fuel is sprayed in and lit on fire, creating an intense burst of hot gases. The heat makes these gases expand incredibly quickly, just like when you pop a balloon. These hot gases then rush out of the nozzle at the back of the engine with tremendous force. This rapid movement of air creates thrust, the same way that water from a garden hose can push against your hand if you hold it close to the nozzle. The faster and more forcefully these hot gases escape, the greater the thrust generated. Incredibly rare incidents might change how much fuel is used or how the engine operates slightly. But for the most part, this process remains constant and incredibly effective at propelling planes through the sky. Okay, so let's talk about the basic components of a jet engine. Imagine you're running an incredibly efficient factory, but instead of assembling cars or phones, it's making airplanes fly. At its core, a jet engine has four main parts, and they work just like a super efficient assembly line. First up is the compressor. Think of this as the part where air goes in and gets squeezed really hard. Just like when you blow into a balloon that's already inflated, air naturally wants to go out because it has nowhere else to expand. But if we squeeze it, it can't just escape so easily. Instead, it gets forced into the next stage of our assembly line. Next is the combustion chamber. This is where the magic happens. Imagine you have a bunch of tiny torches that are all set to ignite at once. You take the air we just compressed and mix it with some fuel, like what powers those torches. Then it's ignited in a very controlled way. It's like lighting a sparkler. Once lit, it shoots out a burst of hot gas. Third is the turbine. After our little explosion in the combustion chamber, we have this super hot and high-pressure air. Now it needs to do some work. This is where the turbine comes in. It's like a whirlwind that spins a series of blades, kind of like a giant windmill. The force from this spinning helps keep the engine running, much like how the blades on a fan pull more air through. Finally, we have a nozzle. This is where all the thrust comes out. Imagine holding a water hose and just letting the water shoot out. That's kind of what the nozzle does, but with super hot gas. When that high temperature, high pressure air exits the nozzle, it shoots out at incredibly fast speeds. This rapid expulsion of air creates an equal and opposite force, thrust. It's like the recoil you feel when you shoot a water pistol. So there you have it, the four main parts of a jet engine: the compressor, the combustion chamber, the turbine, and the nozzle. Just like in a factory, each part does its job to make the whole system work incredibly efficiently. Okay, let's get into the compression stage. Here's the surprising part. Inside that jet engine, there are many spinning blades called compressors. These blades work just like the piston in your car engine, but on a much bigger scale. Imagine you have a super strong fan and it starts spinning really fast. Each blade of that fan is sort of like one of those compressor blades. Now, think about using this giant fan to suck up air from all around the engine. As these blades spin, they push the air in, making it go faster and tighter, just like when you use a straw to drink. But here's where it gets really cool. As the air is pushed into the compressor, its pressure increases dramatically. It's kind of like using a bicycle pump. When you pump up your bike tire, you're compressing the air inside. In a jet engine, it's the same idea, but on an incredibly massive scale. To put this in perspective, imagine trying to fit 10 liters of air into a space that could only hold 5 liters. The compressor is doing something very similar. It's squeezing that much air into a smaller and smaller space, making it much denser. This compressed air then moves on to the next part of the engine where it mixes with fuel and gets ignited. And this compression is super important because it allows the engine to generate so much power from a relatively small amount of fuel. Think about it like squeezing as much juice as possible out of an orange. If you can get more air into the combustion chamber, you can burn more fuel, and that means more thrust for the airplane. So remember, the compressor is doing all this work by spinning very fast and squeezing in air to make it denser. It's a bit like a giant, super efficient straw that can handle volumes beyond anything you could ever do manually. All right, so we've got our air compressed down to a super dense state, like packing your suitcase way too tight until everything is squished together. Now it's time for the next big step, combustion and expansion. Imagine you have this ginormous balloon filled with air. It's really, really full, super compressed, just like in that compressor we talked about earlier. Now, what if you squeezed a bunch of matches into that balloon and set them on fire? Whoa! The balloon would expand rapidly as the hot gases try to escape. That's kind of what happens inside the jet engine. But instead of an ordinary balloon, think of it like this. Once we've crammed all that air into the combustion chamber, it's superheated with fuel added in. And just like lighting a match ignites your overfilled balloon, the spark ignites the mixture there too. Fuel and air ignite in a tiny, controlled explosion. The result is nothing short of spectacular. The hot gases expand incredibly quickly, pushing against the turbine blades like they're trying to escape at breakneck speed. In fact, this expansion is so powerful it's even hotter than a lava lamp. It's like blowing your breath into a balloon, but the heat and pressure are so intense that instead of just inflating, the balloon explodes outwards with such force that it drives those turbine blades around. And here's the surprising part. These turbine blades aren't just spinning lazily. They're turning incredibly quickly, hundreds of times per second. It's like a really fast fan that keeps sucking in more air and pushing out even more hot gas to keep everything moving. So, to sum it up, when we ignite the compressed air with fuel, it's like setting off a super fast fireworks show inside the engine. The gases expand and push against the turbine, making it spin at breakneck speed. And that spinning turbine is what powers your airplane, turning the propellers or driving the jet's core fan to keep it soaring through the sky. And here's the surprising part. Once all that hot gas has rushed out of the combustion chamber, it doesn't just disappear into thin air. Instead, it gets even hotter and faster as it passes through the turbine and the nozzle at the back of the engine. Think of it like this. Imagine you're blowing up a balloon really fast. When you let go, the air rushes out very quickly, right? That rush of air is kind of like what's happening inside a jet engine. But instead of just rushing out in one direction, the nozzle is specially designed to make sure that hot gas moves incredibly fast and in one precise direction. The turbine, which we talked about earlier, is spinning really quickly because of all this hot gas rushing past it. And as it spins, it drives the compressor, making more air come into the engine, and keeps everything going smoothly. But here's where the magic happens. The nozzle at the back of the engine takes that fast-moving, super hot gas and accelerates it even further. It's like focusing a jet of water from a garden hose with its nozzle. The narrower the opening, the faster the water comes out. In a jet engine, this narrowing effect is key to generating thrust. The hot gas shoots out so intensely that it creates a pressure difference between the inside and outside of the engine. This difference in pressure pushes against the surrounding air, creating a forward force, thrust, that propels the plane through the sky. It's all about balance, compressing the air, heating it up with combustion, and then letting it escape at high speed. This careful balance of compression, combustion, and expansion is what makes jet engines so efficient and reliable. And that's how a simple machine can turn the massive aircraft you see in the skies into something that seems to almost fly by. So, to answer our original question, a jet engine works by using a combination of compression, combustion, and expansion to generate thrust. It's like a super efficient rocket on your wing. Air rushes into the engine through the intakes, gets compressed, mixed with fuel, ignited in a controlled explosion, and then expands out the back as high-speed exhaust. This is what pushes the plane forward. And that's not all. Jet engines are incredibly efficient too. They can keep a 747 flying for almost 6 hours on just one full tank of fuel. That's like driving your car from New York to Los Angeles and back, nonstop. Understanding how a jet engine works can make your next flight a lot more interesting and reassuring. When you see that plane zooming past with those powerful engines, you'll know exactly what they're doing under the hood. It's an incredible piece of engineering, and it's what makes flying so safe and reliable. If you want to learn more about how flying really works, more explanations and myth-busting about the fascinating world of aviation, be sure to subscribe. Together, we can explore all the secrets behind those metal birds soaring through the skies.